Yeah. Merging, I will cover that quickly because I think even I am not using the merging task in Tracewrangling anymore that much. I only use it whenever merge cap is leaving me in the dust for some reason. The main reason I put it in was that in earlier versions of Wireshark, merge cap didn't really work well with multiple capture interfaces in a trace file. So if you had a capture that was captured on more than one network card at the same time, merge cap will just throw an error and tell you, no, I can't merge this. It's a strange file or something. So I needed to merge a lot of captures that had multiple interfaces in there. And if you wonder why merging files with multiple interfaces is so problematic, is that if you have two files and there's two interfaces in each file, how do you know that the two interfaces in the files are the same? It's hard to tell sometimes, right? It could be one taken here on two interfaces, one taken over there on two different interfaces. You don't know, are they the same, are they not? So if you merge them, will you end up with two or with four interfaces? Yeah, so that is the problem behind this. And once again, that is one of the things that you have as a network analyst where you don't know exactly what the state on the endpoint was and what the capture exactly was doing and stuff like that. So merging files sometimes is more complex than it seems. So I have options in Tracewrangler that will basically allow you to merge the interfaces by name. So if it sees the capture interface name is ETH0 and the other capture interface is ETH0, it will assume it's the same and merge the same packets on the same interface. But of course, all the systems you have an ETH0, or used to have. I think now they're, in the newer Linux versions or Linux versions, they're named by the vendor name somehow. You could end up with a merged file where you had packets from different capture interfaces merged to the same interface. And that could be a problem. So the option here is, well, merge them by name or create a unique interface for each. So if I have two files with two interfaces, I will end up with four, right? And then I could say, well, I don't care, just merge them down into a single interface. I don't care how many interfaces there are, and then you will end up with a single file with one merge interface. And I think merge cap, I haven't checked it in a long time, I think it does give every original interface a new interface in the merged file. So if you have 100 files with two interfaces, your new merged file will have 200 interfaces in there, which is kind of crazy, but I think that's how it works. All right. What you can do also is, it wouldn't be much useful if you couldn't override the setting. So I put in an interface mapping setting where you can say the original interface here should be that new interface over there. And if you look at the interface names, you can tell that this was captured on Windows systems, because Windows systems, they write the interface GUID into the interface name, which is quite useful because then you know pretty sure that this is the same interface. If the GUIDs are the same, there's basically just a minimal chance that you merge them together and they're not exactly the same. So automatic mapping works best for Windows patches. Very often I just click and go, but if you want to, you can change them. So merging packets, this has a panda here that is kind of thrown off track, and I will show you in a minute why. Because there's something that crashed that I found out yesterday night. Okay, so I need to get out of here. Let's do some merging. Start Tracewrangler again. I have a couple of files here that I can merge together. I will show you in Wireshark how they look like. And I think I should... now it's using the right font size. You can see in here that frame number 1 was captured on interface ID 1. Frame number 2 also on 1. There was one with 0, so we know there's two interfaces, right? One with index 1, one with index 0. You can also tell by looking at the statistics up here. Here you have an interface section that tells you there's one interface and another interface. So this file has two interfaces. The other three do the same. It's exactly capture. It's a basically a capture run that captured into multiple files on the same interfaces. So merging them should be simple. So what Tracewrangling will do, it will allow me to add a merge task. I set it to merge interfaces by name, and then I have interface mappings here where I can see this will merge to that new destination interface, and down here I only have two. So I could map this to a different one. I could say, okay, this one is mapped to interface number 1. This one is mapped to interface number 2. It's hard to see because it's only gray. I don't know if you can see it on the projector. But I could change it and say, I want this mapped to interface number 2 as well. So now it's mapping 2 source interfaces to 1 destination interface. So you're free in mapping whatever you want to. I just press cancel because I want to merge them correctly. Okay, run. And we will have a merged file here. All three of them merged together. And what I also do is I add a packet comment to the first packet of each merged packet so that you know where the first file started, the second file started, so you can go through the comments and see exactly where the cutting points were before. And
can you disable that as well?
I think, I'm not sure if I put in the option, but I will. Because it could be annoying, I agree. So you can see here the merged file has 2 interfaces again, not 6 like there could have been. And it will tell you in the main comment which files were added. So let's just check if I have an option to disable, I think. Because if I don't, I think you can remove this here. Then it will not add the source file names into the packet comments, but I'm not sure if it will also remove the packet comment itself, but I will check that. Should be simple enough. So let's do some other thing and say create a unique interface for each original interface, which means I have 2 interfaces per file, 3 files, 6 interfaces, so my new file will end up with 6 interfaces. So let's see how that looks. Done again. I just reload the merged capture file. And now we should have 6 capture interfaces. So basically now it separates all the original capture interfaces into a new single one. Basically it makes up new interface names. So it doesn't copy the original names anymore, so it creates new ones so that they are distinct again. Okay? Because otherwise you could get into trouble because you have the same name twice, and then if somebody's looking at it and saying, hey, these look the same, why aren't they the same? That's why I create new ones.
So when these captures, this works for captures that have been done on board with PCAP or TCP done.
Yeah.
Either one. I've got some captures with other tools that it doesn't seem to work with. It doesn't identify I don't have an interface ID in there.
Yeah.
So is there a setting in my captures that's telling it that, or is it just the other tool?
No. It's if the file format supports multiple capture interfaces, which is a requirement, then if you know how that interface is specified, then you can pull it apart. That was basically one of the reasons for PCAP-NG, because PCAP can only have one single interface. PCAP-NG can do hundreds of them if it has to, which is one of the reasons why Wireshark with version 1.8, if I'm not mistaken, was able to capture on multiple network cards at the same time, which wasn't possible before, because with 1.8 we started using PCAP-NG where you could have multiple interfaces in a file. So if your capture format that you have has a description for each interface that the packets were captured on and has like a reference from each packet which interface it belongs to, then you can do that. Yeah, so if you have a capture file format that I can't read, I could implement it probably at some point.
I think it's using an old version of PCAP that's embedded in this tool, unfortunately.
Yeah, okay. I think there was some additional header like PPS or something it was called. I'm not sure. But if you have something that doesn't work, just let me know. And if you can get me a trace, I can see if I can put it in there.
Have to randomize it.
Yeah, okay. So, and now for something funny, because it will crash. And I didn't have time to debug it yesterday night. if I map all the interfaces to a single interface, basically reducing the 6 that are fine to a new single one, this will be my panda like going. Okay, so I have an idea why, but I didn't have time to fix it, so I will at some point. But merging is something few people do with Tracewrangling, so the priority is again very low on the list. I will fix it because it annoys me that it crashes. And since I can reproduce it, which is the best error that you can have, it should be an easy fix. But I've said that about working with interfaces and trace files a lot of times, and it's really a nightmare. Having that in a capture program or a trace file analysis program working with multiple interfaces can get really complicated. And I have a lot of additional code in there to make sure that I write the correct packet with the correct interface ID, because very often if you copy packets, it gets you into trouble. So, any more questions to merging? Because it should be pretty simple. It crashes for the last option and it works for the
Can
others.
you merge automatically when you anonymize?
Merge automatically when you anonymize.
Small file set?
No, not right now. That is one thing where I think about the task list being like a chain, where you could anonymize and then merge. Right now, all the tasks that you add will process the same files again and again. So it will run anonymization on all of them and output files, and then it will do whatever the other task does and create a new set of files, so that is kind of useless. I will have to chain them together, and I didn't have the technology for that back then, but I do now. Yeah?
So it's kind of a side tangent, but if I was merging a capture, I often work with VLAN tag packets, and then another capture that doesn't have the VLAN tag packet in the same sessions. Can I merge them and basically strip off the VLAN tags via the merge bits?
That would be a two-step process. You use an edit task to strip the VLAN tags, and then a merge task on the result of that and the other thing that doesn't have it, and merge them together.
Which can all be done basically in Tracewrangling.
It can be done, but it's a two-step process. You need to have an edit task first and then the other thing. Yeah, that is the thing where the task list doesn't make any kind of sense, because it would be better to edit the one thing and then merge them automatically, which it doesn't do right now.
Yeah, right now I use a separate script to strip the VLAN and then merge them myself.
Exactly. Yeah. Okay. Now for extraction. Extraction is basically what I worked on for, I think, the last year before last SharkFest. It is really a very complex thing to do, especially if you're working with multiple capture interfaces, because if you extract them, you need to make sure that everything is matching and everything is fine. So it was not that easy. The goal of extraction is to pull packets from a large set of packets, basically. So if you have like 5 billion packets and you only need one conversation, how to get it. Yeah? And how to get it quickly without opening them all in Wireshark one after the other, checking if something's in there, but doing it quickly. And that's what I wrote extraction tasks for. It usually requires an idea what you want to have extracted. So if you're just having a ton of packets, like a haystack, and you have no idea where you want to go, extraction will probably not help you at all. You need some kind of an idea what you want to do. Most common use case for extraction is pulling full TCP conversation from a big file. For example, you have something that you're looking for, like I want to have all the packets where the HTTP server throws an error. Yeah, you could filter on that in Wireshark. You could say, give me everything where the error number is 500 or greater. But if you filter on that, what do you get? You get all the packets with the error number, right? So if I ask you, what is the GET request that triggered this error? You can't tell me, because you don't see the GET request packet right now, because it's filtered away, because there's no error number in there. So if I need to know which GET request triggered the error, I need to refilter on the conversation to see the GET request that was before the 500 error, and then I know what the problem could be. And that is something that I want to solve with extraction, and that in an automatic way, that you don't have to click and write and filter and stuff like that, but automatically. And I will show you how that works. So, extraction makes heavy use of the metadatabase. It speeds up the extraction process a lot, because if you're extracting a conversation that is in the middle of 100 files, like it's in the 50th file, it doesn't start reading file number 1, 2, 3, 4, and not finding anything until it reaches file number 50, but it knows exactly the conversation starts in file number 50 and it ends in file number 55. So it will start reading in 50, extracting all the packets and stopping at 55, because it knows exactly after 55 there's nothing else. So it's surprisingly fast sometimes. Sometimes I extract stuff and I'm like, why is it done already? Because it knows exactly where all the stuff is. And that is a big advantage if you can do that. Extracting is also powerful because this little feature at the bottom, you can specify the file name you want the results being written to. And you can see here that it by default says source-IP.sourceport dash destination IP destination port. So it will give you one file per conversation, where the IP addresses and ports are part of the file name. But if you say, well, I want all the TCP connections between those two IP addresses in a single file, just remove the port numbers, then it will write them to one single file where there's just the IP addresses, and then you have everything between those two in one single file. So playing with the file name and creating a good file name pattern can make a huge difference. It can mean you get a lot of small files, or you can aggregate the stuff into single files. Yeah, so I will show that as well. And yeah, demo. Let's just try to find something interesting here. I think I already have a shortcut. Let's do the file set thing. This is a file set that I have. It is, I don't know how many megabytes, 15.4 gigabytes. So who has worked with that amount of data before and processed it in one single go? A couple of people, but not that many. Okay, so
Not a single one.
yeah, not a single one, because in Wireshark you have to open them all manually, one after the other. Or you can do T-Shark if you're a command line cowboy like Sake is, which I can recommend. T-Shark is a solution to many problems where you can do automation in a great way. If you are interested in that, go see Christian Lundström's talk. He's a colleague of mine, and he's doing T-Shark stuff, I think, today. I'm not sure, but you will find him, and he will show you how to do stuff automatically. Let's run Tracewrangling again. There it is. And as you can see, I already have a database file up here, which is 212 megabytes, because I added all the files already. I just add, let's say, 20 files. And then you can see how fast it will get all the metadata back, because it will just read the database for that. So let's drag and drop them on here. And now you can see it's reading the database. So instead of scanning the file each and every time, it will now just read the results that it already gathered before from the database again. So it's a lot faster than having to rescan everything all the time.
Does it do some sanity check to make sure the database is consistent with the file?
Yeah, it does a lot of sanity checks actually. So that was another interesting thing. If you're interested in that, I can just give you a quick overview how to recognize that the trace file is still the same. How do you think a trace file, how can you determine that a trace file is still the same? If you have a database entry saying, I know this about the trace file, how do you know that the one on the disk is exactly the same like the one you have in the database? You could do a hash, but that will break as soon as somebody adds a comment in a pkg file, because the hash will be different, but the file contents will be still the same except for the comment, and the comment is nothing that I need in my database. So the hash is a good idea, but it only works for files that don't allow the user to add annotations and stuff like that. Okay, other ideas? Because I solved the problem already. Well, basically what you can do, the hash is a good idea. What I also do is, or what I do mostly is, unless it's pkbng, I look at the file size. If the file size is the same, it could be the same file, but it could also be another file with the same name that is just the exact same size. So what I do is I read the timestamp of the first packet. And if that's the same and the file size is the same, it's the same trace file. Alright? Unless it's pkbng, because if you add a comment to pkbng, the file gets bigger. So the file size isn't the same, the first timestamp is still the same, but I don't know, has there something been merged or what happened? So what I do in pkbng, and that is the genius of pkbng, is, I don't know if you know this, but you can read a pkbng file from the back as well. It's designed in a way that I can start reading at the end. So what I do for pkbng, I read the first frame timestamp, I read the last frame timestamp, and both are the same. I assume it's the same file. If it's not, I start rescanning it again. So that's how I do it. And then Pascal, at some point, gave me a trace file that broke and crashed Tracewrangling. And the reason for that is that he wrote something where the interface description was in the middle of the file, not at the beginning, which it usually is. And I wasn't expecting that. So I couldn't read the last frame because I didn't know the interface entry. And that was a little problem, but I fixed it. I'm doing a little trick now where I read the last frame timestamp with the first interface I have. I don't care if it's correct or not. I just need a reading that is consistent, and that works. So, yeah, sometimes the Wireshark developers break my stuff too, like I break theirs. So. All right, so everything's in there. I can do an extraction thing now, but I don't know what I look for. So what am I looking for? And let's just do a little example. Let's get the, let's say, why do I keep closing my stuff? I always have to open it again. Let's open one of the capture files. It takes a while because it's Qt and that's slower than GTK. Alright, so let's say we want to find stuff where web servers break. So let's say http://response code greater or equal 500, right? That means the web server sends me an error, something is broken. Let's check how much we get. Come on. Can you see the bottom? There it is. Filtering. There are the errors. So now I have the problem that I know that there's 140 something error frames in here, but I don't know what are the GET requests for those errors, and I want to have the GET requests. So what you would normally do now in Wireshark, if you're not using T-Shark, which would allow you to do some automation as well, you would go and right-click on this. No, right-click, not left-click. The touchpad is sometimes doing funny things here. Come on. And then you'd go for conversation filter TCP. Or follow TCP stream if you are having fun with closing this extra window all the time. So conversation filter TCP would give me the conversation, right? Okay. Do you believe me or do you want to see it? Because if I click on this now, we have to refilter again for the error 500 code. Oh, let's do it. I have enough time. So it's filtering. And you can already tell why I wrote something about extraction, because this is so annoying. It just takes too long. Because imagine it's 140 error messages, and now I'm filtering this 140 times for one single file, not all of them. One single file. So there's the GET request, get barn ticket something. Barn ticket in German means a train ticket. This is from an application that does travel search stuff for you. It's a real life example. It's not anonymized and nothing, but the project doesn't exist anymore, so I just use it. And you won't get the traces anyway, so it's just for demo. So this is the process that you would have to go to find all the calls that result in an error 500, and then you can bug the developers of this thing about. What I want to do is I want to automate this stuff. So what I do again is I go back to filtering on the 500 error, and you can go to sleep for half a minute again. All right, so I got my packets. So what do we do now? We extract the packets. I write all the error code packets to a new file. Let's say web error 500 for file number 1.pcap.ng. Is it written correctly? Yeah. No. Put the number there. All right, so far so good. Everybody knows what I'm doing. I'm just extracting the packets with the 500 error into a new file. Christian is always giving me trouble. Why do I write the pcap.ng ending in the end? Because it will add that by default anyway, so you could also do this. All right, so now I have a new file. It should be down here somewhere. Let's check. And you can see it's only the 500 errors, right? Or whatever error there is. There's a lot of interesting stuff in there. So now I want all the conversations that have this error. This is where Tracewrangling comes in. I already have loaded all the files. As you may have noticed, I only pulled the 500 errors from the first file, so running them against all the files right now is kind of too much. I would have to extract all the 500 errors from all files before that. I would do that with T-Shark, and the reason why I can't do the extraction of the 500 errors in Tracewrangling is because Tracewrangling doesn't really filter on complicated stuff. It only can filter on IP addresses and ports. But if you want the full power of the Wireshark filtering system, you need to run T-Shark or Wireshark to get the indicator frames that you need for the extraction. So what I do now, I add an extraction task. And now here you can see there's something called a flow filter. This here will allow you to specify which conversations you want. So we could now look into the Wireshark display and get all the IP addresses and ports and add all the stuff ourselves. But we're lazy, right? I mean, network analysts, they're like, do I really have to do that? I don't want to do that. I'm not doing that. So what I do here is I add a filter. I show you how it would normally work. You add a filter like this, which is very clumsy compared to the cool filter bar in Wireshark, but I'm not a programmer, I don't know how to do that. So what I do now is I import from file. You could also do a lookup, which will give you, again, the metadata, where you could select one that you want, but you don't know which one has the 500 error code. So I import from file, and now I select my capture file with the 500 errors. Down here. So what it will do now, it will read this file with all the 500 errors and build conversation filters for each packet it finds. So each new conversation it finds, and there's only one per error, I hope. Maybe there's 2 errors in one conversation, but then you will have only one conversation filter for it. I just click OK, and I get filters for everything. So basically, this is a list of all the conversation in the huge file set that I want to have extracted. Okay, so I need just one packet to get IP address, source IP, source port, destination IP, destination port, and now it can extract from me the full conversations that have the same IP and port and TCP or UDP combination. And it should be 140 or something, maybe less. 133. So we have a couple of error messages that are twice or more times for one single conversation. Okay? So what I can do now is, well, output it into a new file separated by source IP, source port, destination IP, destination port. So I will get one file per conversation. Right? In a subdirectory called extracted. And I said, let's just go crazy and do it. So here's the file browser. I go to the top because that's where the extracted directory will appear. And now I run the task, and I hope that it won't crash, because sometimes when I demo it crashes. So here's the new extracted directory that was just created by Tracewrangler, and you can see all the pcaps now being created here. If we go for date modified and sort it by that, you can see all the single conversations appear. Yeah, if that's too much for you and you don't want 133 different files that you have to open in Wireshark one after the other, just sort them by source IP, or write them by source IP, or write them by destination server IP, which would be probably making sense because you're trying to fix a single server instance maybe. So let's see how far we are. Basically the task is done. Why is it done so quickly? Because again, with the metadatabase, I know that I'm only looking for stuff in the first file. So as soon as I process the first file, I'm done. Yeah, if I would have carved or pulled the error message from all the files, it would continue until it gets to the last one that it needs to extract and then stop. So this is really quick. It will only do the work that it has to and not go to everything. So we can look at the files now and say, well, basically what I usually do is I drag and drop in onto Wireshark, because that's the fastest way to open files for me. Just take the first one, drag it here. There's just one packet in there, that can happen. Let's take a bigger one. I still have the filter in there, yeah, thank you. That's fine. It's good when you have people in the audience that actually try to find the problems that you're making or creating. Okay, so here's the full conversation, and now I can see the GET request and everything that happens until at some point there's the internal server error, so I could use that now to basically try and fix the problem, right? So the other thing that I maybe want to do is, and I remove all of these again because I can recreate them really quick. Let's change the extraction to give me one file per destination IP, and maybe destination port, because I don't know, maybe the service runs on different ports as well. So I remove the first part of the file name. So now everything is written to a file with the name of the destination IP and the destination port the packets are going to. All right? So let's see what happened. I clicked again. Let's see how that looks like. Run. Now I get one file per server. You can see here there's, for example, this 132.80. So now I probably have a couple of conversations in there. No, not that many, but that's how it works. So basically you use the import feature for the file to create filters and then write the results by file name to a new file. And that allows you to extract stuff really quickly. Okay, so inspecting now all the different problems that you have, or the remaining trace files, is much quicker than going through them by hand and looking at them one after the other. So that is how the extraction task works. For a simple search, I will show you later how to, or maybe we'll do it now. I don't know. How much time do I have, Saki? Do you know?
Half hour.
Until when?
Half hour till
Half hour. Wow, that much? Okay. All right. Then, also I wanted to show how to extract indicators of compromise. Who knows what an indicator of compromise is? Betty knows, Saki knows, a couple of people know. So indicator of compromise is real simple. It's a thing that tells you that somebody's attacking you, or basically that somebody is breaking into your network and trying to break in or successfully breaking in. So if you know about WannaCry, who has heard about WannaCry? Everybody probably should have. What they're using is a NSA exploit that got into the wild. So if you're trying to see if your network is having this attack traffic that is used by WannaCry, you can look for the pattern that tells you this is the WannaCry attack, or this is the eternal blue attack, that is basically the thing that they're using. And if you have this specification, and very often these are IDS rules, intrusion detection system rules, or Yara rules, or Snort rules, which is an IDS system, you can look for attack patterns in your network traffic. It's like a virus scanner for packet traces or live traffic, depending on if you have a system that can inspect traffic live. What happens a lot is that if you have an IDS system telling you that it has seen the attack pattern, it will give you one packet where the pattern is. Right? So, like with the internal 500 server error, you see, oh, there's the attack pattern, but you don't know what is happening in this conversation. What did the user do? Was it on a web page? Was it, what web page was it? Stuff like that. So once again, you only have a single packet, and you need more than that. You usually need at least the GET request. You need to know what happened before the attack pattern showed up and stuff like that. And that you can do also with Tracewrangler in combination with Node. So if somebody tells me we may have a compromised system, like a server that is probably infected or has been taken over by a bad guy, what I often get is a packet capture of the system doing what it does. So I get like a day worth of traffic for this server, and then they tell me, can you find an indicator of compromise? And this can be like a couple of hundred gigabytes that I have to look through. So how do you do that? Basically, the answer is pretty simple. You don't do it by hand, because that would be stupid. Yeah. So if you're ever trying to look for a certain pattern in a lot of packets, what you don't do is open them all in Wireshark one after the other, because it will take forever, and you may still miss it. So what you do instead is you let some tools automatically scan all the traffic for you to find this malicious pattern. And the one that I recommend to use is, in this case, Snort, which is an open source project. If you don't know it, snort.org, I think, is the URL. There's also Suricata, which is a newer system which works similar. You could also use that one. I'm using Snort to do my demonstration here. Yeah, basically what Snort does is look at the PCAPs, see if it finds a pattern in the list of defined patterns that it has, and then tell me there's a packet that matches the pattern. Okay? And I will do all of that for you just now so that you can see the whole process. Alright, so I need a command line for that, because Snort is not a GUI tool. So what I will do here is I will probably increase the font size so that you can see more. Is that big enough for you in the back? Alright, okay. So let's go to my demo traces. Alright, so SharkFest, Tracewrangling, support. Okay, I have a couple of captures here, 3 PCAPs with stuff in there happening. A lot of normal stuff, but also some attacks. And how do I check my PCAPs for attacks now? What I have is a Snort installation on my laptop here that is configured to run with a certain set of things to look for. So I wrote a little command script that will process the PCAP files, and I should change the font as well. Where's the font setting? There it is. You can see it will just basically call snort.exe, which is in C snort bin snort.exe, and it will read the list of files it should work on from a file called pcaplist.txt. That is just a list of files that should be processed. And then it will have to show me what it's currently working on, and then there is a configuration file containing all the signatures, all the patterns that it should match. Now that is where the patterns come from. And if you want to see the patterns, we can just take a look at them real quick. Just go there. wants to open an application, let's say use, usually I use Ultramate for this. So this is the snort configuration file, and in here there's a lot of things that it should look for. And there's also an include for the rules, and in the rule files there's actually the patterns that need to be checked, and I don't know which one it is right now. I think local rules and the SO downloaded rules, so we can check if we can find those. Not in there. Rules. Looking for SO downloaded rules. Should be here somewhere. There they are. So this is how those things look like. Who's ever seen a snort rule before? Just a few of you. The rest hasn't. Basically what it does is it tells snort what to look for. For example, this one here. Alert TCP external net. So snort gets a configuration what is external, what is internal, so that it knows where it is and what is considered to be friendly and unfriendly. External is unfriendly. So look for stuff coming from the external network on HTTP ports, coming into the home net to any port, and look for something that is called here. The content specifies what bytes to look for. 3C object, that means binaries or hexadecimal 3C, and then the string object should be found, and if that's found at a specific location, then this is considered to be a hit. So snort rules basically are, hey, look at this kind of traffic coming from there to this one, and see if you can find this pattern at that location, and if it is, let me know. Yeah, that's what it does. Yeah.
How sophisticated can you get with the filtering?
Very sophisticated.
Time between packets?
Yeah. You can even do stuff like filter on stuff in this packet, and if you find it, set a flag that alerts me when I do the other check that it has been set, and then if that happens too, then I only raise the alert. So that is called what they call flow bits. So you can raise flow bits and say, I've seen that one, that isn't enough for me to alert you, but if you see this and that also, alert.
I was actually looking for something where the time changed.
Yeah,
The amount of time it took between.
Yeah, you could do that. Yeah, it's really complex. You can do almost anything that you can dream of. Yeah. So that's really nice, and basically many people run that on live traffic in their networks, but I use it offline to check PCAPs that I get, because I can't put snort stuff everywhere where I want to go. I just tell them to get me PCAPs, and then I check them offline later, which has the advantage that I have everything, and I can carve everything out that I need. Okay, so now we know how the rules look like, we know how the configuration looks like, we can close it again. So what I'm still missing, and I should remove the zoom again, I don't have the pcaplist.txt, right? That's not there. As you can see, there's only the process command, and this is 3 pcaps. So what I do right now is real simple. I say dir/b. /b means don't show me the full path, because otherwise a dir would give me everything, and I don't want that. dir/b, and then I say star or sh.pcap. So now I get all the file names that I need, and I pipe them into pcaplist.txt. So it should not display that on my command screen here, but put it in the file. So now I have something called pcaplist.txt. Yeah, there's the files in there, and now it knows what to work on. So now I can simply run the command process dir, and you can see it starts, and now it will read the 3 files and check for funky stuff. Yeah, sometimes there are some deprecated rules, so we don't care. Go. I have no idea what it's doing right now.
Quick question, while it's working?
As long as it's working, it's fine with me. So.
Sorry, quick question while it's working?
Yeah.
Can the snort rules be snorted?
Yes, actually, you can have hits on snort rules that, if that's the question. So I had a couple of incidents where people were looking, there were indicators of compromise, like this URL is bad. And then people were checking if that URL was in their systems, and they were distributing the snort rules for that, and the snort picked up the transfer of the snort rules and triggered the alert, because some had already updated to the newest rules, and then the new rules for other system passed that system, and it raised the alert, and everyone was like, oh my god, we're hit. That is something that can happen. The same thing often happens if you give non-technical people the indicators of compromise, and they start checking for them in their web browsers, just to see what it is. And then the alert system will be like, oh my god, we're infected. And I had big companies shooting themselves in the foot like this a couple of times repeatedly. So handling indicators of compromise is something where you need to be careful with. So come on, it's done with the first file, it's now acquiring the second file. We can already look at the results, because it will create a new trace file for each file that it checks. You can see here snort.log.something. This is basically a PCAP file. Unfortunately, it doesn't have a PCAP extension, but it is a PCAP file. Yeah? And if you're writing something like a Tracewrangler, you can check that real easily by opening an hex editor. Yeah, welcome, don't worry. And here you see D4, C3, B2, A1, and every core developer right now is like, yeah, this is a PCAP file. That is the magic strings at the beginning of the PCAP file that tells you this is a PCAP file. Alright, so how far are we? Still working on it. Okay. Well, what I can do already is show you one of the PCAP files that were created.
How big those files are scanning?
How big?
Yeah.
How big the scan?
It's climbing network traffic from short snort capture to PCAP.
Yeah, it's 3 files. It's done with the first, it's working on the second right now. Now it's working on the third, I think. Let's check. Yeah, now it's reading the third one. So it's reading the one after the other. Or what was the question?
The problem that I was researching, I had limited the file size to 200K because it was too slow to load into Wireshark.
Yeah.
And I had thousands and thousands of these files that I had to look through. I ended up writing software to do it.
Like we all do, right?
I couldn't do it myself, not visually, it's not possible.
Yeah.
But it was a little quicker than this.
Yeah, but this is checking like, I think, 40,000 rules against all the packets.
Oh, okay.
I don't know how big the downloaded SO rule file was, but I think it was about 40,000 rules that are checked against each packet. So if you do a smaller one, and if you tune snort to just check for the things that you really need, it's much faster. It can almost do it in line speed. So, and it can handle any file size you want, so you don't need to do small files. All right, so it's still scanning, but no, it's done. All right, thank you. So what we have now is we have new files. We have 3 PCAP files. The PCAP files that it creates are the files for each original file with the packets that had a match. So I get single packets per match, not the conversations, just the single packet. I also get an alert file that basically tells me which things were hit. For each hit I get one block here, and it tells me there's an SSH scan brute force. There's somebody is brute forcing SSH here. There's IPv6 encapsulated over IPv4, which is not really a security problem, but it's a tunnel protocol, so Snort has rules for that as well, so that you can detect IPv6 riding on top of IPv4, because sometimes security rules may not really deal with those. We have some D-shield block, a couple of things happening here. So what happens now is usually that I want to check out what really is in those files. I hope that was a Wireshark instance here. So you can see I get a lot of single packets. For example, again, HTTP 11403 forbidden. So there was a match that gave me this single packet. Something was forbidden, but we don't know what it was, right? Because we only have the single packet where the hit was, but not what the GET request was before that. So once again, I'm having the problem of having single packets. So what I do now is, again, use Tracewrangler to carve me all the stuff that I want to know. Close this one, start a new one, add all the original ones, not the extracted ones. You can see now they get scanned. This is how long it takes to scan a file of 153 megabytes. It's not really blazingly fast, but it's good enough for me. Of course, if I can find a way to make it faster, I will. Right now, the default way of making it faster is buying faster SSDs. So, now all my original files are in here. Now I need to build an extraction task. I add my filters again from file. But instead of going for the PCAPs that I had, or the single packets that I have, I do another trick. Because I'm using the alert log. Why am I using this instead of the extracted PCAPs? Any idea?
Covers all three.
It contains matches for all three files, yes, correct. But it could also add all of them one after the other or all together. That would be possible. But the other thing is, in the alert file, there's much more information than just the PCAP. In the PCAP, there's just a packet that had a match, but I don't know why and what happened. The alert file is an exact thing that tells me this was a hit because somebody brute forced this at that time and so on. So it has much more information. And if I put this one in here, it will automatically realize this is not a PCAP file, this is a Snort alert result file. So it detects that automatically. And what it will do now, it will add a filter label for each conversation that it will extract that will give me the name of the rule that was hit for this one.
So add that as a packet comment?
It will add that as a packet comment, yes. So I have that here now. Filter label will tell me, okay, this conversation will be extracted because brute force tools fake putty version and stuff like that. Okay? So, okay. Now go to the output label, and you can see here again I have this source IP, source port, and so on thing. But what I will do now is I will basically create a new subdirectory. Let's say extracted is fine, but here I will put a placeholder for the filter label. Remember, the filter label was the name of the rule that matched, right? So now I will get one conversation per hit in a subdirectory that has the name of the rule that was hit. So all of the hits get grouped by subdirectory by rule name. You can put the placeholders in the directory name or the file name wherever you want to. Okay. Now let's check run. We should get a new subdirectory here, extracted. And we get a new subdirectory name for each rule that it finds. And in there I get one file per hit, and I can drag and drop it to, where's my Wireshark? I don't know. The zoom is, let's say this one. So I can drag and drop it over here. And now this is the conversation that had the hit. I can see through colorization, I colorize my commented packets in green. I put a color rule in there, so if there's a frame comment, just make it green so I know which one it is. And in here, there's once again the rule name that tells me this is the packet that had that rule match this packet. Yeah, so now verifying this kind of stuff is really simple. I just need to open one file after the other. And you can imagine I had one case where I had to investigate, I think, 140 single conversations by filtering the manuals. So I had to find out in which file does it start, in which file does it end, give me all the packets, merge them together, look at them, then find out it was nothing, then do that for the next one. It took me half a week to do that. And that was the moment where I said, wait a minute, I got a tool that could do that for me. So Tracewrangling is now extracting that stuff for me. So basically, you need to have Snort run to find the indicators or the alerts. And then I just run Tracewrangling on all the files with the alerts and look at the results. And then I only have the conversations that are basically hits for IOCs. And I can say, this is a problem or this is not a problem. Or other way around, if you're like, well, me, you're looking for bad stuff. This is okay. I found bad stuff. But for my management, this would be better. Yeah, so if I find bad stuff, they don't like it. Or the customers that I work for.
Yes,
yeah.
This is now a two-step process. Are there any plans to make like a box that you can select an external tool? Okay, give me packets or sort alerts, and then do it automatically?
Not yet, but that is something that I could add. Basically, making the one-step process so that you say, this is a file set, please use Snort with this rule set and run it and do everything for me and just give me the files. Yeah. It's quite possible.
Or run T-Shark on this file with this filter.
Yeah.
And then,
that is something I had in mind, but once again, 24 hours per day. I don't know.
So sad you made it in Delphi.
It's so sad that I made it in Delphi, I know. So many people would work on this if I didn't. Well, that's... I told the story again. Why did I do it in Delphi? The reason for this is I'm not a programmer. So I used what I knew, and the alternative would have been to learn C for 10 years to be good enough to do this, and by then I would have shot myself already probably because of having to do it in Delphi. Yeah. So the reason for being it in Delphi is simply because I knew how to do it, or I thought how to do it, because right now if I look at my old code, there's stuff happening in there where I thought, why did I do that? It's so stupid. I could rewrite everything, but I think that is the same for all programmers. Whenever they see old code, it's like, why did I go through all that trouble instead of using this simple thing? All right, so how much time is left? 15 minutes. Okay. Then enough with all the task stuff. Come on, go away. Still working on it. It's not really fast, but it's a lot faster than doing it manually. I need an abort button.
As long as the progress bar is accurate.
Yeah, it's accurate, but it should be abortable without using Process Explorer. Okay, that's it about the task. Now I want to show you something that I really use when I do network analysis quite a lot. And for that I need my file set again. I should go. And I'm just going to add, let's say, 10 files. Because 10 files should be enough to get you the idea. Once again, it's reading from database. The interesting thing now is that as soon as it's done reading the metadatabase, in tools you will have something called communication details. This will not be available if the file hasn't been scanned or if there's no file. So now if I open it, I get something that looks a lot like the conversation statistics in Wireshark, if you have ever seen it. The one that I'm working on most is the TCP conversation, and you can see it's 100,647 TCP conversation in those 10 files. This is something that you probably won't be able to do in Wireshark, as at least if I will say I'm going to hit you with 500 gigabytes, then I'm pretty sure Wireshark will not be able to do it. So what it does here is it will show you conversation statistics over all the files that are currently in the file list. So if I add a new file to the list, or if I remove one, the conversation statistics will be recalculated each and every time. So it will always be representing what is currently in the file list. And a lot of things in here you already know. It's like address A, address B, address port A, port B, packets, how many packets from A to B, how many bytes from A to B. What I added as columns is the packet ratio. That is basically added to allow me filtering for those where one side is talking to the other but nothing is coming back, which could be an interesting thing, right? So you have a one-sided conversation happening. And you could also do that by filtering, of course, on packet A to B, but if there's a few packets, but the other side is doing all the talking, the percentage rating will allow you to see where the conversation is not really balanced. So you can basically just sort the column by who's talking the most with the other one being real quiet. That was the one reason why I added this. Then I have an initial RTT, initial round trip time. Who knows what that is? Initial round trip time. Basically, that is what TCP needs to go from client to server and back. So the time that it takes for a packet to go to the other side and the answer for that packet to come back. Usually it's calculated on the three-way handshake. I have a blog post on how to do it correctly if you want to look it up. I put it in here because sometimes you have conversations that have really crazy initial round trip times. I mean, this one has a 71-second initial round trip time. So the handshake of saying synac egg was 71 seconds. And these things are quite interesting because I can understand if a user is complaining if the handshake alone takes 71 seconds, right? Okay, so the other things I have then are the flags. It's an egg push syn fin. Basically all the flags that I've seen in the conversation. So it's not per packet, but everything that I've seen. When do I have it seen first? And the last column is one that tells me about the handshake and teardown process. So I know this conversation is complete. There was a complete handshake, there was a complete teardown. It is kind of slow, not to say it is eternally slow, because 71 seconds for a setup is like forever. But I know it finally worked somehow. So the big question would now be, what on earth was happening in this conversation, right? So what you can do now is you can go and right-click and say, well, give me a Wireshark filter, A to B and back, or A to B in one direction or the other direction, and all that kind of stuff. But what I also can do, and that is what I do most, I just double-click on it. And what will happen then, and you can see it at the bottom for a short amount of time, it will go into the correct trace file, extract the conversation flow for you, open Wireshark with the extracted file, and show it to you.
Even to multiple trace files?
You can do that with multiple trace files, but the problem is whenever you extract something, it will overwrite the old temp file. So sometimes I shoot myself in the foot by extracting a couple of things, and I still need the old one, which is still open in Wireshark, and then I try to browse, and it tells me the file isn't there anymore. The problem is here that I need to basically pipe the results into Wireshark, and I'm going to talk to the devs in Wireshark how to do that.
But this could span multiple trace files in your...
Yeah, it will pull, I mean, if it starts in the first and ends in the file number 1000, it will go through all of them and get it.
Save it right away.
Yeah. So basically what you can see here is somebody sending a SYN. There's a SYN egg coming back because this was captured in front of the server. So we see the SYN incoming, the server saying SYN egg, but obviously the SYN egg doesn't go through. SYN egg, SYN egg, SYN egg, SYN egg, and so on. And then finally there's an egg, and then crazy stuff happens, and this is like a trace where you can tell, okay, this guy is having problems because somehow the conversation from the server isn't getting back through. And imagine you have like 15 gigabytes of trace added, and by simply sorting a row or a column and double-clicking on it, you already have found something where you can say, this is not looking okay-ish. All right, so I use that a lot when the customer said to me, capture some data in our networks and see if you can find anything. If you get a task like that, it's very often like, what am I looking for? Because usually I need some indicators of this server is slow, this application is bad, look at this, look at that. But they were just like, hey, capture something and let us know if something is kind of strange. So I was using Tracewrangling a lot. I was just putting everything in there and just sorting by various things and then looking at what was going on. I think here, I don't know if I have GeoIP enabled, I should have. Yeah, what you can see here is this is the hoster where I am at. FNH Media is where my server is at. And the client is coming from Telefonica. So this can tell you a lot because it's probably a handheld device on a very bad whatever mobile connection. And that is probably because why the SYNAC didn't get back to the handheld device and has had to retry so many times. Yeah, so sometimes GeoIP is a good thing because then you can see what could be the reason why the SYNAC doesn't make it through. Because in a wired connection, this is just ridiculous. I mean, 71 seconds. Normally you would have terminated the session long ago. So there's some other stuff. I also have this here. Handshake and teardown after multi-SYN retry. So Tracewrangler will basically do a quick check on the handshake process and see if there's something that is not working as it should. So let's extract that. And again, we have here SYN, SYNAC, and then a retransmission for the SYN, which basically means that the other side probably didn't get the SYNAC back. So once again, this is a problematic connection. And with this, I very often just try to find interesting things. Let's just sort by status column. There's a lot of problems here. Come on. Okay. It will also tell you if it spans multiple files. So if a conversation is in more than one file, it will say spans multiple files. Well, okay, all right. Let's just say I've got a few that I'm interested in. There's no teardown. This is, for example, is also a problem. SYN send. So you only see the SYN packet, but not the SYNAC, so somehow nothing is happening. Now let's say I want to look at all of them. So I select them. That's enough. I could right-click on them and say extract to either a single file with all conversations that have this problem or that are in those rows, or give me multiple files, one per row. So I once again get the single file per each. Let's say a single one, and I call this, let's say, SYN send.pkapng. I'm in the snort directory, but I need to go to the file set one. Down here, you will see that it says extracting frames, 25% complete. So right now it's basically jumping over everything that it doesn't need, which is why the percentage sometimes stops. And you can see also the file name tells you which file he's, right now it's number 9. Now it's number 10. And we're done. So now I should have one file in there. With all the SYN sent. And there they are. Right? So we even have some destination unreachables in here. Interesting. So the SYN must be down here. Yeah. Okay, so this trace is actually interesting because it will tell you that Tracewrangler, like Wireshark, will look at TCP even if it's in a quote of ICMP. and it will extract that as well, which is really helpful because that way you get the error message with the quote and you can see what it is. Right? I mean, this doesn't look like much because now everything else is missing, but I extracted something where there was nothing else except the sync packets, right? So this looks like there's no more, and there is no more. Okay, so I think now I'm done. Let me check my slides. I think there's only one thing left to do, and that would be, well, that was the tools right now. And now for the roadmap. One thing I want to do is be able to adjust timestamps. This is something that has to do with incidents. If you're publishing a capture file where the timestamp is exactly matching a note in a newspaper where it says they were attacked on that day, and you find a PCAP where the day is exactly the same, that could be like an indication that this was something from that company. So adjusting the timestamps and moving them to one side or the other, like add a couple of days, add a couple of minutes, remove a couple of months, stuff like that is what I want to do. And I want to do it in sync with NTP. So if there's NTP in the packet, I want to adjust the NTP timestamps as well so that they stay in sync, so that you can tell from the NTP that this was changed. I need to add more protocols. DNS is the thing that needs to get in there as fast as possible because a lot of other protocols are dependent on that. Even HTTP is dependent on DNS because the www.wireshark.org is basically nothing else than an FQDN that comes from DNS. So if I'm changing those, they need to stay in sync as well. So DNS is basically the key to everything that is on top of TCP. I need to rewrite my loader so that it can handle files bigger than 2 gigabytes because there are some people nagging me about that. I also want to add ERF file support because what I don't like, I don't know if you had that problem, you get like 4 terabytes of capture files and they're in the wrong format. So you're spending a day to convert them to the format that you need. I don't want to have that. I want to start working right away, so I'm going to add ERF, should be simple enough. And then the biggest challenge will be implementing TCP reassembly, which is, as I already said a couple of times, a nightmare, and to improve the processing speed. The other thing that I forgot to mention is I can compile a binary for macOS and probably Linux if I buy a more expensive version of Delphi. The problem with that is that the GUI won't work, or I can't compile it with the GUI, but the idea is to maybe build a command line version that you can just run on the command line with a parameter set that you define in like a JSON or XML file or something like that, and then just have it run natively on all the platforms. But that is something that I'm going to check, basically. So the code is written.
My checkbook is in my purse. I'm just saying. We can talk about that.
I'm doing it for free, as you know. So.
Well, I mean, you have to buy the more expensive thing.
Yeah, it's very expensive. The idiots.
You get subsidized by people who like the Mac.
Yeah. The Mac is not the problem.
Oh, it's the Linux.
Apparently, the Linux version is. They say, oh, you want to build a Linux version, which is open source and totally free and everything. You need to buy the enterprise version. By the way, that is a 4-digit number. I'm like, what? No, not so far. I will try to get a command line version for the Mac, and if that works, I would then think about the Linux thing. Because there's a lot more Mac users trying to get me to do a Mac version right now. You too, and Sake, and many other developers.
Since it runs in Wine, I'm going to explore the Wine Walker some more.
It runs in Wine, as far as I've seen. I've run it a couple of times myself in Wine, so...
Wine runs on the Mac as well.
Yeah, even the 64-bit version runs in Wine, so... Yeah. Alright, so that's it. The version that I have been showing here was compiled yesterday night. It's not digitally signed and nothing. The new version will be on my website probably next Sunday or a couple of days later because I need to build it at home. If you want it faster, come see me and bring your USB stick and I'll find out if you are infecting my computer sooner or later. Okay, thank you and have a good SharkFest.